You are listening to The Vocal Technologist. Spoken tech for your ears.
There is a very specific, unique kind of terror that strikes when you realize you are holding a full, dangerously hot mug of coffee directly over your brand new mechanical keyboard.
Oh, absolutely. You know the exact feeling.
One slight flinch, one bump of the elbow, and suddenly you're spending your entire weekend pulling off keycaps and cleaning sticky linear switches with a tiny cotton swab.
It really is a brilliant reminder that no matter how advanced our tech gets, we are always just one clumsy physical moment away from complete disaster.
Spot on. You can have the most robust enterprise-grade architecture in the world, but
no firewall can protect a local machine from a spilled flat white.
Exactly. And as your resident vocal technologist, I'm thrilled you're joining us to unpack some brilliant new developments in web dev and AI. I have spent hours poring over the massive stack of repository notes, articles, and research papers you sent through for us to look at.
We have a mountain of fascinating material to get through.
We really do. We are custom tailoring this entire exploration specifically to unpack how AI is fundamentally altering the way we build software. We want to get right into the gritty technical realities of front-end development and analyze some enormous shifts in industry hardware and models.
It is an incredibly dynamic environment. We are moving from high-level philosophical shifts regarding what it even means to be a developer, right down to the byte-level optimizations in server infrastructure.
I reckon we should jump straight into this concept of clay Bugattis you highlighted because it is such a perfect analogy for the state of AI-generated code.
Yeah, the barrier to entry is lowered so drastically.
It is incredibly easy to produce software that looks like it works perfectly. You get the sleek interface, the buttons click, the animations are smooth. It feels entirely real, but it is an illusion.
A clay Bugatti looks absolutely identical to the real car when it is just sitting idle in the showroom under the fancy lights. But the moment you take it out on the highway and try to push it to its limits, the wheels fall off.
Right.
What we are seeing across the industry is a widespread confusion between the act of simply building an app and the actual rigorous discipline of engineering a system.
Because the AI can generate the clay model effortlessly.
Exactly. But it lacks the contextual understanding to engineer the chassis underneath.
I hear that, but if that works for the end user and gets the job done, do they really care if the underlying architecture is a clay Bugatti? I mean, if the UI is fast, the user is usually happy.
They do not care until they hit an edge case, which is exactly where engineering a system becomes critical. Engineering involves architecting for reliability.
Dealing with things falling over.
Yes, dealing with complex state mutations, race conditions in a shopping cart, managing WebSocket reconnects when a user goes through a tunnel, and building for massive concurrent scale.
AI tools are fantastic at generating the happy path.
But they are notoriously bad at anticipating the cascading failures of distributed systems.
Which brings up an incredibly interesting point for you as a listener. If the AI is handling all the boilerplate code and handing us the shiny clay model, what becomes the defining skill for a developer?
Looking through the research, the answer seems to point clearly towards taste.
Taste. It becomes entirely about how a product looks, feels, and flows.
And taste is not just some innate magical gift that you either have or you do not.
Yeah.
It is a highly trainable instinct. You develop taste by immersing yourself in exceptional work.
You have to stop and analyze the mechanics of why something feels good.
Spot on. Is it the specific easing curve on the animation timing? The typographic hierarchy, the empathetic way it handles error states? You build that mental library of patterns, and you use that library to act as a creative director guiding the AI.
Because we can direct these models to build functional prototypes so quickly, we are entering this era of software for one.
Which is a massive paradigm shift.
It really is. This is the idea that engineers can just vibe code custom software on demand, specifically for their own hyper-niche personal use cases.
Instead of paying monthly subscriptions for massive bloated software as a service applications.
Exactly. If you need a highly specific budget tracker that integrates with your exact bank and your exact spreadsheet format, you just prompt it into existence.
It is incredibly empowering. We are moving from software as a scarce, expensive commodity to software as a disposable utility. But that shift also fundamentally changes how we feel about the profession of software engineering itself.
That perfectly tees up the 747 pilot analogy from the notes. There is this growing sentiment where modern developers are starting to feel like pilots of a commercial airliner.
The pilot is undeniably highly skilled.
But the plane basically flies itself for the vast majority of the journey. Coding agents are reducing the need for developers to have a deep line-by-line understanding of the underlying syntax. They are managing the overall flight path rather than manually working the ailerons and flaps.
It is a profound psychological shift for a lot of engineers. You are moving from being a traditional craftsperson who shapes every single line of code by hand to an operator who orchestrates and manages complex, semi-autonomous systems.
It requires a completely different cognitive load. So I have to ask the obvious question that always follows this topic. Are software engineering jobs actually dying out?
It is the most common anxiety in the industry, but we need to look objectively at the macroeconomic facts. AI is not systematically killing software engineering jobs in the way people fear.
So the sky is not falling.
Not at all. The market contractions we are observing are heavily driven by broader economic factors. We had a period of excessive speculative hiring driven by incredibly low interest rates. What naturally followed was a sharp correction when those interest rates increased and capital became expensive.
So the research data shows no systematic increase in unemployment directly attributable to AI automation.
Precisely. What the data does highlight is suggestive evidence of slower hiring for junior workers in highly exposed entry-level occupations. The jobs are not disappearing, but the traditional entry path of writing basic boilerplate code to learn the ropes is evolving rapidly.
Juniors now need to level up their architectural understanding much faster.
Spot on.
Speaking of which, that structural integrity issue bleeds perfectly into the debate around agent tooling. If agents are going to be doing so much of the heavy lifting, how do we build the right tools for them to interact with our systems?
It is a massive debate right now.
There is a strong argument emerging that Model Context Protocol servers, or MCPs, might be a bulky dead end, and we should actually be returning to standard command line interfaces.
It sounds completely counterintuitive to go backwards to old-school CLIs, but the engineering logic is incredibly sound. CLIs are naturally composable via standard input and output streams.
And they're completely debuggable for both humans and large language models.
Crucially, they do not require you to run persistent background processes or manage complex server connections just to execute a single stateless tool.
Wait, handing an AI agent a standard bash terminal sounds like a recipe for a wiped production database. If the agent hallucinates a destructive command, standard CLIs do not have guardrails.
That is the exact danger, which is why we cannot just use standard CLIs. We need agent-first CLIs. An agent-first CLI has to be completely redesigned from the ground up.
Prioritizing raw, structured JSON payloads for inputs and outputs instead of human-readable text.
Exactly. It has to offer runtime schema introspection, meaning the agent can ping the tool and ask it to explain its own parameters on the fly.
And what about stopping those destructive hallucinations?
That requires rigorous context window discipline through field masks. You only give the agent the specific data fields it explicitly needs to complete the immediate task.
Because if you give a model a massive JSON dump full of irrelevant metadata,
its attention mechanism gets diluted and it gets confused. Good input hardening and strict field masking are non-negotiable when giving agents execution privileges.
a brilliant example of this in action is the Google Workspace CLI we looked at. It interacts with Drive, Gmail, and Calendar, but it dynamically builds its command surface by reading the Google Discovery service.
So it automatically updates its own capabilities whenever Google releases new endpoints.
It gives human developers nice tab completion, but it feeds the agent structured JSON and over 100 pre-built skills.
It is an absolute masterclass in building a unified interface for both human and machine operators simultaneously without compromising the experience for either.
Now, to be fair, there is a strong counter-argument here. Vercel took a very different path with Next.js. They spent a whole year trying to build an in-browser agent called Vector.
The ambitious goal was to help the AI physically see the internal framework state, inspect the document object model, and read browser console errors directly.
But they ultimately sunset that entire project in favor of a dedicated MCP server for Next.js.
They found the MCP was actually far superior for their specific integration needs. It allowed for tighter, more reliable coupling with the internal routing and state management of the framework than an external browser agent could achieve.
So the CLI versus MCP debate is far from settled.
It really depends on the specific environment you are trying to expose.
And while we are talking about agents executing complex tasks, there is this fascinating architectural setup someone shared for running 4 to 8 parallel coding agents. They use tmux alongside Markdown-based feature designs.
It is such a clever approach.
You write out your problem statement, your proposed solution, and your verification steps purely in Markdown. Then you spin up different autonomous agents acting as product managers, planners, and workers, all executing concurrently in isolated Git work trees.
What is particularly interesting about that specific setup is the language choice for the agents themselves. Go is widely considered the absolute best language for developing these autonomous tools.
Why Go specifically over something ubiquitous like Python or TypeScript?
It comes down to the feedback loop. Dynamic languages like Python often fail at runtime, which means the agent has to execute the code, hit the error, and try to parse a sometimes cryptic stack trace.
Whereas Go is compiled.
Yes, its compiled nature and strict static typing mean it fails at the compilation step.
No.
Furthermore, the incredibly fast compilation speeds of Go mean the agents can iterate rapidly.
They write the code, compile it instantly, catch the deterministic syntax errors, and rewrite it.
It allows for a very tight, highly efficient, and predictable feedback loop for the model.
Let us pivot slightly and look at some pure web dev feats and front-end struggles, because there is some mind-bending data here. Someone ran a massive static analysis across 500 popular open-source front-end repositories.
The results were staggering, and a little terrifying for anyone maintaining a large code base.
They found that 86% of those repositories have missing cleanup patterns.
We're talking about things like instantiate a side effect hook in React without providing a proper cleanup return function, or subscribing to a global event listener and never unsubscribing when the component unmounts.
The metric they attach to that is about 8 kilobytes of leaked memory per mount and unmount cycle. Honestly, 8 kilobytes sounds like absolutely nothing in an era where we have gigabytes of random access memory.
It sounds tiny until you understand how quickly that compounds in modern web architecture. If you are building a single-page application dashboard that a user leaves open in a background tab all day,
Or a desktop application built on web tech that runs persistently.
those 8 kilobyte leaks stack up every time a user navigates between views. The garbage collector cannot clear them because the references are still active. Eventually, the browser tab silently crashes out of memory, or the app grinds the entire machine of the user to a halt.
Doctolib actually ran into some major architectural issues building their React Native AI chat on mobile. Streaming the AI responses token by token was completely breaking the standard mobile scroll patterns.
The UI just could not keep up with the rapid re-renders.
They had to open source an entirely new list component just to fix the jank.
But the genius move they made was not just the UI component, it was changing how they checked for data updates. They switched from snapshot polling to event polling.
Snapshot polling is essentially asking the server for the entire state of the chat to compare to the local version, right?
Exactly, which is incredibly heavy. Event polling just asks what specific events occurred since the last check. That single architectural shift eliminated roughly 80% of their wasteful network requests and CPU overhead.
On the topic of massive architectural shifts, we have to talk about Patreon. They just completed an epic 7-year migration of their entire front-end codebase. 11,000 files, 1 million lines of JavaScript, all painstakingly moved over to strict TypeScript.
A 7-year undertaking requires incredible institutional discipline. You have entirely new teams cycling in and out over that time frame.
They started organically, built up their continuous integration checks to enforce boundaries.
And for the final massive push, they utilized AI-powered codemods to handle the really complex, undocumented legacy code that human developers were afraid to touch.
For you listening, if you want to avoid those kinds of sprawling type definition headaches, the notes highlight a great architectural pattern emerging around React, using a contract-first approach with OpenAPI.
This is absolutely crucial for stopping your front-end types from drifting away from your back-end API responses. You make the OpenAPI specification your single undeniable source of truth.
You generate your TypeScript interfaces and your runtime validation schemas automatically from that spec.
And when you are building out your data fetching, use query options to define your fetch functions at the router level, rather than locking yourself into messy custom hooks.
Why are custom hooks considered messy in this context?
Custom hooks often obscure the dependency arrays and make it very difficult to implement things like server-side rendering or prefetching before a component mounts. Query options provides a much cleaner abstraction that works seamlessly with modern file-based routing.
Let us give the backend infrastructure some love too, because Platformatic pulled off an absolute magic trick. They managed to cut their Node.js memory usage in half. 50% less memory footprint.
And they achieved this with zero changes to their actual application code.
It is a brilliant piece of platform engineering. They achieved this simply by swapping their base Docker image to enable V8 pointer compression.
In a standard 64-bit architecture, Memory pointers take up 8 bytes each. By compressing those internal pointers down to 32 bits, they only take up 4 bytes.
And that halves the memory, but does it not add CPU overhead to decompress them?
There's a microscopic CPU cost, but the net gain is massive. Not only does it have the overall heap size, but their latency actually improved.
Because the total memory footprint is smaller.
The garbage collector has significantly less memory to traverse and sweep, meaning the pause times are shorter and the application responds faster.
Amazing. And Vercel had their own back-end magic trick. They needed to scale their web redirects to infinity. They were sharding their massive redirect data into JSON files, but parsing those entire chunks of JSON into memory was causing massive performance bottlenecks on their edge network.
So instead of deserializing the whole chunk, they implemented a binary search algorithm directly over the sorted redirect keys within the raw JSON shards.
They can pinpoint and retrieve individual redirect data instantly, reading straight from the disk buffer without parsing the rest of the file.
Is the perfect example of applying foundational computer science algorithms to solve modern cloud infrastructure bottlenecks.
Let us bring out the heavy hitters. We need to look at the latest models, security updates, and hardware drops. The model updates are coming thick and fast. OpenAI released GPT 5.4, which now features native computer use capabilities.
These agents can literally take control of the mouse and operate across multiple applications on your desktop.
They also dropped GPT 5.3 Instant, which is specifically tuned for smoother, less preachy, everyday conversational cadence. Meanwhile, Google dropped Gemini 3.1 Flashlight, which is just absurdly fast and cost-efficient for massive batch processing.
The raw speed of iterative improvement is remarkable. But what is equally fascinating is the illusion of the AI vendor mode. Anthropic just added a direct memory import feature to Claude.
You can simply export and paste your entire accumulated context, system prompts, and user preferences directly from ChatGPT or Gemini into Claude.
It proves that there is absolutely zero vendor lock-in within the LLM ecosystem. The switching cost for a user is practically zero.
Now, looking objectively at the facts outlined in the research regarding the United States Department of War, there is a significant security update we need to cover.
The facts are that the Department of War officially designated Anthropic as a supply chain risk to national security. This designation occurred because Anthropic explicitly refused to allow their AI models to be integrated into military autonomous weapon systems.
Anthropic has publicly stated they believe this risk designation is legally unsound, and they are planning to challenge it in federal court. They also noted they are still offering transitional enterprise support to the department during the dispute.
Concurrently, the department signed a new infrastructure and model deal with OpenAI. Observers in the security space have pointed out that the terms of service of OpenAI regarding military use cases are structured differently and are perceived as less restrictive than Anthropic's.
Those are the stated positions and actions of the involved organizations, just laying out the facts there. Moving on to hardware, Apple dropped some major surprises. We have the new M5 MacBook Pros, the new M4 iPad Air, and the absolute shocker, the MacBook Neo, aggressively priced at $599.
The Neo is going to radically expand access to Apple Silicon for students and junior developers.
Yeah.
But from a pure engineering perspective, the most impressive hardware news comes from the open source community.
A developer managed to collaboratively reverse engineer the Apple M4 neural engine.
They bypassed the proprietary Core ML software layer entirely, mapping the undocumented hardware registers so they could directly compile and execute matrix math code on the bare metal silicon.
That level of hardware hacking is just phenomenal. But we have to end this segment with a fairly terrifying security warning from the academic papers we reviewed. Researchers have definitively proven that LLMs can de-anonymize pseudonymous online accounts at massive scale.
And they can do it for an API cost of just $4 a target. It completely shatters the illusion of online anonymity.
The researchers built a sophisticated 4-stage extraction pipeline.
It pulls identity-relevant features like location hints, writing style, and temporal posting patterns from completely unstructured text across different isolated platforms.
The model embeds those features into a vector space and uses advanced reasoning to confidently match a Reddit profile to a LinkedIn profile, for instance.
If you thought posting under a fake name protected your identity, the math now proves otherwise.
So, to wrap all of this up, we have covered an incredible scale of innovation. We are looking at an environment where agents are parallel coding our applications in isolated work trees, where we are finding and fixing massive front-end memory leaks with new event-polling architectural patterns.
And where direct Bare metal hardware access and new models are fundamentally changing what a computer can do autonomously. We are rapidly transitioning from the era of writing rigid programmatic instructions to the era of orchestrating fluid intelligence.
It is a completely different world.
It is. And that leaves us with a fascinating historical parallel to ponder. Consider the Swiss watch industry during the quartz crisis. They were absolutely decimated by superior, highly accurate, and exponentially cheaper Japanese quartz technology.
Traditional handcrafted mechanical watches became functionally obsolete as practical timekeeping tools.
So to survive complete irrelevance, the Swiss industry had to pivot. They stopped marketing themselves as makers of precision instruments, and they transformed into luxury brand marketers. They sold heritage, emotion, design, and status. I want to leave you with this question. If AI makes the production of flawless, highly complex software incredibly cheap and ubiquitous, will the tech industry experience its own brand age?
When the raw code itself is a freely available commodity, does the brand become the sole driver of the value of a software product? That is a brilliant thought to end on. Thank you so much for joining us for this conversation and letting us explore these ideas with you. As always, we invite you to subscribe for more explorations into the wild and wonderful world of web dev. Catch you next time.
Spoken Tech for your ears.